extra practice on solving quadratics by graphing, I want to quickly talk about what solving means once again to make sure we remember this. So when we're looking for solutions, we're also looking for a term called zeros. And they're called zeros because we're looking for where the function is y equal to 0, or where they cross the x-axis. It's like 4 ways to say the same thing. So for a type of equation that has 2 solutions, it's going to intersect the x-axis twice, or blue here. Now, if something has 1 solution, that means it's going to be intersecting the x-axis 1 time. And something that has 0 solutions will never intersect the x-axis. And this is going to be really helpful as we start working for these types of problems. So let's do one more quick example. And let's find the solution to this quadratic function. So step 1, let's figure out the a, the b, and the c values for what we're working with in this function. So the a value is 1. The b value is -2, and the c value is -3. Once again, we have to figure out what the vertex is to decide what the center of our table should be. And our vertex is opposite b over 2a, which in this case is 2 over 2 times 1, which is 2. So the center of our table is 1 again. From here, we make our table on the side. And the center of it has to be 1. So you can pick as many points as you want beyond this, because all we really care about is where are we going to intersect the x-axis. So once again, I'm going to pause the video, and I'm going to ask you to figure out what these ordered pairs should be. Now, this is what our table ended up looking like, and pardon my really tough graphing on the left here. It's very hard with the bamboo board. But we need to figure out now what the zeros, or the solution to this quadratic function, would be. Now, there are 2 places that it's intersecting the x-axis, or 2 places where the y value, where the y value is equal to 0. Now, that means our solutions have to be 3, 0, or -1, 0. If I plugged these into the equation, these are also the places where the y would have to be equal to 0. So you could solve these without a graph, but I think the graph is the easiest way to do it. So now this begs the question, why are we learning this? Like, what is the point? How does this help us with the types of problems that we have been working on? Well, if I'm given a graph with a problem on the left, and it's written in the form ax squared plus bx plus c equals y, and I need to figure out what the equation is, the problem is it's very, very hard to put it into this form. And those of you who have been doing Desmos have seen that and commented on that. It's very, very hard to put it in the correct form. So we have another method to help us, that we can write it in a different form, and this is Galen's method that he's been working with for months. So when our zeros are x equals -2 and x equals +1, we can actually write it as x minus the opposite. So in this case, it would be x plus 2. And in this case, it would be x minus 1. And we set that equal to y. If I had this function and I FOILed it out, I would end up having the same thing that I have been working with since the beginning, which in this case would be x squared plus 1x. Whoops, that should be an x, not a y. Plus 1x minus 2 equals 0. These graphs are the same. But it is going to be so much easier to work with this one, especially in Desmos. And let me show you what I'm talking about. So we have this problem here for our marble slides. Okay, if we click launch, our marbles fall right there. We automatically get the stars on the left. So we need to be able to intersect the axis somewhere around, let's say, like 18 and 22. So if I tried to write in the form, like 6x squared, plus 4, and I try to shift it to the right, and it's really hard to do. But now, if I know I want it to intersect at 18 and 22, I go x minus 18, parentheses, x minus 22. And I automatically have it in the right form. Okay? Now, if I wanted to shift it up or down, I just add or subtract values on the back, shifting it up or down. Now, if I wanted to flip it, I put a negative out front. If I wanted to make it grow wider, I make the number in front smaller because the growth rate is smaller. And that's actually what I'm going to do for this one. So I have my function now like this. So I did 1/10. And if I drop it, it hits and it rolls up, and I'm missing 1. So I'm going to put a little roof over here. So if I go y equals 30, and we'll restrict it from, let's do like 30 to 40. Let's see if this works. So I got to tilt it a little bit. But as you can see, when I'm working on these types of lines, it's actually so much easier if I'm able to write it in non-standard form. Okay? So I want you to, when you start to work on these types of problems, I want you to really start to think about, like, how could I think about these zeros to help me write these in slightly different form? Let's see if I can get it to work now. After all of this talk about getting it to work. Oh, so close. Let's try 65. There we go. So, as always, if you have any questions, please let me know.